Hi guys, so this week we're going to continue talking about arithmetic sequences, which are patterns that we looked at, but this week we're going to really look more at the way to write the rules and then just focusing on the common difference between the numbers, because I think we have a solid idea of how to, finish a pattern by using a common difference. Okay, so common differences, just to kind of go back over that, is the increase or decrease from one term to the next. So if we have 4, 8, 12, 16, 20, the common difference is going to be 4. If we were decreasing, so let's say that we were taking away 5, then our common difference would be -5. So always just pay attention. Am I increasing or decreasing to look at your common difference? We have two types of rules, and one is our explicit rule, and I talked about that in a video last week. And then we also have our recursive rule. So explicit rules are really easy to plug into because if I say what's the 5th term or what's the 10th term or what's the 99th term, you plug in whatever number that you're asked of. So our rule is f of x equals 5x minus 1. And an example question would be, well, what is the 5th term? So you just have to plug in 5 for your x value here, okay? And so when you do that, you have 5 times 5 minus 1. So 5 times 5 is 25, minus 1 is 24. So 24 would be the 5th term in the sequence. But if you were asked to do the 10th term, you could do the same exact thing. You could just plug in 5 times 10 minus 1, or you could be asked like the first 4 terms or whatever, but you would just be plugging in whatever term they asked into the x value. That way you could easily get your answer. And so here, I gave an example of that. So if we had the rule f of x equals x plus 8, to get the first term, you would plug in 1. So 1 plus 8 is going to be 9. Okay, and then you would do your second term. 2 plus 8 is going to be 10. 3 plus 8, 4 plus 8. If I said, what's my 100th term, you would say 100 plus 8 to get 108. So you can just easily plug those into the explicit rules, no matter what it is, to find out your terms. The recursive rules look scary, but they're actually pretty easy. And so your recursive rule gives you a starting point. And so, like, in some of the examples that you looked at last week, you might start at whole number 12, and then you're adding 4 from there, okay? And so that would be a recursive rule because you're starting somewhere, and then your common difference isn't like what your starting point was. We're not starting from 0. And so f of 1 represents your first term. And so with a recursive rule, I'm starting at 6, but then I'm continually adding 4. So my first term would be 6, and then I'm going to add 4. So my second term would be 10, and then I'm going to add 4. And then my third term would be 14. My fourth term would be 18. My fifth term would be 22 because I started at 6, but this rule here is just I'm adding 4 each time. And so this is just saying I'm taking the previous term and I'm continually adding 4, and this right here was my starting point. So that's kind of the difference between the two rules. This has a given starting point that's different from 0, and then here this tells me, what my rule is going to be, whether I'm adding something or subtracting something, multiplying, dividing, or a combination of all of these things. But usually your recursive rules are pretty straightforward. If they're going to be a little more complex, you're going to see that in an explicit rule form.